Now we will move on very important topic of applications of differential equations. So where we can use these differential equations in real life as well as engineering and physical science and economics and medical, so many fields we have lot of applications. We can solve so many problems by using differential equation. So differential equation by using solve so many problems, various fields. I will show some PPTs or where we use of differential equation various different fields. So are you able to see? So differential equations is depends on rate of changes. So these principle based on so many problems solving by so many fields, fields solving by so many problems. For example, per a day. So next we use it chemical reactions in chemistry. Then planetary motion. Then next we use in weather and climate prediction and population growth. It is very most important of population growth in using of differential equation. So then rockets, motion of the rocket is also very important using of differential equation. Then financial market, then planetary motion. So airflow across a plane's wing and radiodetectivity of decay and tumor growth and brain function and suspension bridges, electrical circuits, vibration of guitar strings. These are examples of using differential equation solving of so many problems. Especially we can solve differential equation in that most important Newton's law of cooling. So what is Newton's law of cooling? So before we know the Newton's law of the cooling, I will tell to one example. So in this subject, how we are using of differential equation of differential equation. So for example, so take a cup of a coffee. Instead it has a temperature, it has 30 degrees centigrade. If you put it in a stove or fridge, after 10 minutes you observe what is the temperature of a cup of coffee. So temperature may increasing or decreasing, or it depends on surroundings medium. So where we can place cup of coffee. If we put a cup of a coffee in a freeze, after we observe 10 minutes, the temperature will be decreasing less than of 30 degrees. After we put in cup of a coffee in stove, after observe 10 minutes, the temperature will be decreasing more than 30 degrees. So in this example, what we observed, so here rate of the change of the temperature in our surroundings. So Newton's law of cooling statement is the rate of change of temperature of body is proportional to difference between temperature of the body surroundings medium. So Newton law of cooling. So in this Newton law of cooling, how is using of differential equation. So for example, we will take first temperature body theta. Temperature body is theta. Then surrounding medium temperature is theta 0. Surrounding medium temperature is theta 0. Then we can write it. What is the statement of Newton's law of cooling? The rate of change. How to denote it, rate of change? So d theta by dt. The rate of change of temperature of the body is proportional to difference between the temperature of the body surroundings medium. So it is first starting temperature theta, then surrounding medium temperature theta 0. So what is the difference between both? We can write it theta minus theta minus theta 0. Theta 0. So what is Newton Coulomb law? The rate of change. So we can write it d theta by dt is proportional to theta minus t0. Now we remove the proportional. We can write it d theta minus dt equals to plus or minus k into theta minus t0. So here minus d theta by dt equals to minus k into theta minus theta 0. So the temperature always will be decreasing. That's why we put it minus. So here k is constant. How to solve up the differential equation? It is one differential equation. dt theta by dt equals to minus k into theta minus theta 0. So how to solve? So it is using by using of variable separable method. So what is variable separable method? Separation of variables. So in this we can apply separation of variables. We can write it dt theta by theta minus t0 is equals to minus k into dt. So after separation variable we can do integration. So next integration of d theta by t minus t0 equals to minus into k into d theta plus c. So 1 by theta minus t0 integration is log of theta minus t0 equals, here is minus k is constant, its right side 1 into d theta. 1 into d theta is integration is t. So that's why we can write it minus kt plus log c. Then theta minus t0, here is c, if transpose right hand side it is division, then theta minus t0 is equals to, here is log, if transpose left side it is base e to the power of minus kt. So theta minus t0, here is division, if transpose right hand side it is c e to the power of minus kt. Here is theta equals to, here is minus t0, if transpose left side it is plus. So we can write it t equals to theta 0 plus c e to the power of minus kt. Next, let initial temperature of the body theta equals to theta 1. Initial point, that time is t equals to 0. The two values substitute in above equation 1. So what is equation 1? Theta minus t0 equals to c e to the power of minus kt. So what is t here? T equals to theta 1. That's why we can write it theta 1 equals to here t0 plus c e to the power of minus kt. So minus k into 0. So theta 1 equals to t0 plus, here is minus k into 0. So e to the power of minus 1 value 1. So I can write it 0. Here theta 1 minus theta 0 equals to c. This is c value. This c value substituted in equation 1. So what is equation 1? Theta minus t0 equals to c into e to the power of minus kt. So theta is equals to t0 plus c. C value theta 1 minus t0 into e to the power of minus kt. So c value is substituting t1 minus t0. So here is t0, t equals to 0. Here is t is equals to 0. That's why we can write it. We will get c1 equals to theta 1 minus t0. So what we will get? Theta equals to t0 plus t1 of minus t0 plus e to the power, into e to the power of minus kt. So this equation we will get to find out temperature at any time. So if we know temperature, we will find out the time. So if we know the time, we will find out the temperature. So this procedure by using to find out the temperature at any time by using of Newton's method cooling. So these are many applications of differential equation in many subjects. So in this session we have learned about what is differential equation, where we origin from differential equation, order and degree of the differential equation, and how to formation of the differential equation, and how to solve of the differential equations by various method, by using of variable separable method and homogeneous functions. And we know the some applications of where we use of applications of differential equations in so many fields. I hope think it is understanding of the our topic. So thank you. Um, and thank you giving this wonderful opportunity. Thank you.